Friends, today we will see Hill Cipher. Now, Hill Cipher is a classical cryptography method. It uses linear algebra to convert plain text into the ciphertext and ciphertext to plain text, that is encryption and decryption procedure. Now, this Hill Cipher uses or converts blocks of letters at a time. So instead of one single letter, as in a simple substitution cipher we saw, it converts one single letter at a time into the ciphertext. Hill cipher converts blocks of letters, means more than one letter, it converts into the ciphertext at a time. It uses polygraphic or polyalphabetic substitution cipher. As we are aware, there are two types of conversion process, monoalphabetic and polyalphabetic. So monoalphabetic and polyalphabetic. In alphabetic, in monoalphabetic cipher, it converts a plain text into the ciphertext. For example, A is converted as S. For example, just so A is a plain text which is converted into the S ciphertext. So then each occurrence of A in a plain text is converted as S only, and that is known as the monoalphabetic cipher. Whereas in polyalphabetic cipher, the occurrence of A in a plain text is converted into the by using different letters, maybe by using the same letter. So it may be converted as S, it may be converted as P, it may be converted as X, or so on. So that is the polyalphabetic cipher. So Hill cipher is an polyalphabetic cipher, as well as it converts a block of letters into the ciphertext at a time. So it increases the security as it's a poly. So conversion from ciphertext to plain text is difficult as we can't do the frequency analysis here. This Hill cipher is developed by Lister S. Hill in 1929. Now, what it uses or how it converts the plain text into the ciphertext. So, for conversion and decryption, encryption and decryption process, it uses the matrix multiplication. It means somewhere we have to use the matrix operations, and so we have to require a key which is a matrix type. So it should be a square matrix. It may be the 2 by 2, it may be 3 by 3 or 4 by 4, but it should be a square matrix. So our key should be a square matrix, and then for multiplication, as it's a matrix, so we have to convert the plain text into the blocks, and that blocks should be the n by 1. So it is a vector. So P should be n by n square matrix, and plain text we have to divide the plain text into the n by 1, the size of this key. So like this we have to convert, and then only we can do the matrix multiplication or matrix operation. It uses the modulo 26 operation, as there are 26 alphabets. So it uses the modulo 26 arithmetic and polygraphic encryption. So encrypt multiple letters simultaneously. So these things we have to do. We will see by using the example how it converts plain text into the ciphertext. In any cipher, we have to convert the alphabets of plain text into the numbers. So this is a numbers. A is denoted with Z, B is 1, and so on. So Z is denoted by using the 25. Now we will take the plain text as the, for example, our plain text is consider plain text as a show messages. This is our plain text. So show message is our plain text, and the key is here given as a hill. So key K is a hill. The word is hill. For hill cipher, convert this key into the matrix form of n by n. As there are 4 letters, so we have to write down these 4 letters into 2 by 2 matrix. So it is denoted by like this H, I, L, L, and this becomes our key. So key is converted like a matrix 2 by 2. As this is a 2 by 2 matrix, we have to divide this plain text also in the pair of two letters each. So these are the pairs. And now in the last pair, you can see there is only one single letter. So you can attach here one in it letter, and it makes this becomes our plain text. So plain text P, first is sh. So we will see this how sh can be converted into the cipher text, and what is the cipher text for that. So first of all, convert all these alphabets of plain text as well as key into the numbers. And now these are the numbers for the key HILL. So key is HILL, and the numbers for this one is 7, 8, 11, 11. And our plain text is SH. Now the method for conversion encryption from by using Hill cipher is C is equal to K into P mod 26. Now K is key, P is plain text, mod 26. When we perform this multiplication, then we will get the cipher text. K is a matrix, so 7, 8, 11, 11, that is Hill is our key, and P is plain text. We took SH as first two letters for our solving purpose only. We will first convert SH, and the remaining letters you can track to get the complete cipher text. So S is denoted as 18, H is denoted as 7. So write down this as a 2 by 1 matrix mod 26. Now do the matrix multiplication. So 7 into 18 plus 8 into 7, this one. Then 11 into 18 plus 11 into 7, mod 26. So 7 into 18, we will get 126. 8 into 7, 56. 11 into 18 as 198. Plus 11 into 7 as 77, mod 26. Add these numbers, we will get 182, 275, mod 26. Now 182 mod 26 becomes 0, remainder is 0. 275 mod 26, remainder is 15. So at the end, we will get the vector as 0 and 15. Now convert this 0 into the alphabet. So it is A and 15 is P. So our cipher text is AP. So for the plain text SH, cipher text, so our plain text was SH, and we are getting the cipher text as AP. Sorry, P is not P, AP. So this is plain text and this is our cipher text. So this is the method of conversion or encryption by using the Hill cipher. Now we will see the decryption process by using the Hill cipher. Now for Hill cipher, the formula for conversion or decryption is, now we have to convert the cipher text into the plain text. So plain text is equal to K inverse into C mod 26. This is the reverse of the encryption process. So K inverse into C mod 26. Now K, as it is in the form of the matrix, so we have to use the procedure to convert matrix invertible form, that K inverse we have to find. Now K inverse is possible if it satisfies certain condition, and that condition is GCD of determinant. GCD of this determinant, one second. GCD of determinant A mod 26. So determinant of A mod 26. First find out the determinant of this matrix, modulus 26 and the 26 number. If the GCD of that two numbers is 1, then only K is invertible, otherwise not. So now we will first find out the determinant of K. So determinant of K, that is, if it is 2 by 2 matrix, then 7 into 11 multiply diagonal elements minus 8 into 11, we will get 77 minus 88 as minus 11. This is a minus number, so convert it into the positive equivalent. So process is add 26 here, so we are getting the 15. So determinant of k is 15. Now 15 and 26, if we will find out the 20 GCD of that one, it is 1. There is no common in 15 and 27, 26. So GCD is 1. Now find out this 15x modulo 26 means inverse of 15. You can use the trial and method, or you can use the uh, Euclidean method, extended Euclidean method to find out the inverse of 15. So by using trial and method, we will get 7 as the inverse of this one. So inverse of 15 is 7. It means inverse of this determinant k. So determinant k inverse is 7. Now to get the K inverse, matrix inverse, we require the adjoint of K also. So actually the formula for K inverse, to find out the K inverse, means any K matrix inverse is 1 upon determinant of K into adjoint of K and mod 26. This is the formula. So we found out 1 upon this, 1 upon determinant of K, and that is 7. So this value we got it 7. Now we have to find out the adjoint of K. So adjoint of K for 2 by 2 matrix, write down this 2 by 2 matrix. Now 11 for adjoint. Adjoint, I think all of you know, still I will tell you adjoint of A. Suppose this is a matrix A, B, C, D. Then adjoint is equal to D. This numbers, change the place of these numbers and then make this as minus, put the minus sign. So this is the adjoint. So because adjoint of K becomes 11, 7 and minus 8, minus 11. Now make these numbers as positive. So add 26 in that. So we will get 11, 18, 15 and 7. Next step is now K inverse. So now we have the adjoint of K. We know upon 1 upon determinant of K, that is 7. So 7 into this value mod 26. Now multiply these things, say by 7, multiply 7 with this matrix, we will get this one. Now the formula, we saw the formula P equal to K inverse into C mod 26. Now we have the K inverse. So this value 77 mod 26, 126 mod 26 becomes the, now we are getting this matrix as, sorry, we are getting this matrix as 25, 22, 1 and 23. So this is our K inverse. This is our ciphertext 0 and 15 mod 26. Do the matrix multiplication. We will get the P value as 330 mod 26 and 345 mod 26. If we do the mod 26, we are getting 18 as a remainder and 345 mod 26, then 7 as a remainder. So if we are converting these letters into the alphabets, then 18 becomes S and H is 7. So SH, we are getting SH successfully back by using the AP. So first of all, we converted SH by using encryption process, and then AP, we converted this ciphertext to SH again by using the decryption process. Hope all of you understood this encryption and decryption process by using Hill cipher. Thank you all. We will stop here. and the remaining letters from the show messages. Now you have the K, you have the K inverse, so it's very easy to find out the remaining plain text or convert remaining plain text into the ciphertext and back to the ciphertext to plain text. Thank you all.